We are starting our first topic in college algebra. We're going to be looking at solving equations in this chapter and solving different types of equations. So the first thing that we're going to look at is solving linear equations. So you should be familiar with solving linear equations from your previous math classes. So hopefully this is just kind of a quick review. We might get in a little more extensive problems than you've done in the past, but may not. So after I talk about linear equations, I'm hoping you know how to solve these linear equations, solve equations that lead to linear equations. So when we first look at them, they might not actually be a linear equation, but as we go through to solve it, it becomes a linear equation. And hopefully then we'll also be able to solve application problems involving linear equations. So what is a linear equation? So a linear equation can be written in the form ax plus b equals 0. So it may not be in this form, but it can be written in this form where we say that a and b are real numbers. They're fixed real numbers. So notation-wise for real numbers, you can look at this capital R that I just wrote with a double vertical lines on that R that represents real number system. So A and B are real numbers, and X is the variable. We have one stipulation. In order for this to be a linear equation, X cannot equal 0. So notice the linear equation, that variable, the exponent on that variable, it's not shown. So that exponent is 1. So all linear equations are going to be in this form or could be written into this form. Okay, so you need to recall on how to go through and solve these types of equations. And so when we first start, we might not get something that looks like this. It might be a lot messier. So maybe let me just pause and see what you guys think about, or think to yourself, what are things that you do in order to solve linear equations? Okay, so I had some awesome comments coming through the chat explaining what to do when we're trying to solve equations. So to solve an equation means to find the solutions that make that equation true. So solutions to an equation can be written in a solution set. One method for solving equations is to replace the original equation by equations that are equivalent. And we can do that by doing certain things to both sides of the equation. If we do something to one side of the equation, we also have to do it to the other side. And so some things that we want to do are isolating our variable. So getting all the terms that have our variable in it to one side of the equal sign, and getting all the terms that don't have the variable in it to the other side of the equal sign. And so first thing that we would do in order to do that is we would either add or subtract like terms on both sides of the equal sign. A lot of times before we even start moving terms to each side of the equal sign, we like to simplify by combining like terms on each side of the equal sign, and then start moving things around. So adding and subtracting like terms is one way. Once we've done that and we've gotten all the variables to one side of the equal and the constant to the other side, we want to get that coefficient, that number in front of our variable, to be 1. And there's different ways that we can do that. We can either multiply by the reciprocal of what was in front of that variable x, or we can divide both sides by what's in front of that variable x. So here are a couple of simple, hopefully simple, linear equations. So in front of you, we have 6 plus 3x equals 9x plus 6. So that's our first equation we're going to look at. So looking at that, notice that 6 plus 3x, those are not like terms. That 6 doesn't have an x on it. So we can't combine those. We can't add those. And then on the other side of the equal sign, we have 9x plus 6. So there's nothing else that we can do there to simplify that side of the equal sign. Okay, so it's simplified on both sides of the equal sign. So now we want to get the variables to one side and the constants on the other. To me, I don't mind which side you get the variable on. Some instructors may like you to get it on the left-hand side of the equal sign. It doesn't really matter to me. So getting the variables, if I wanted to do this, if I got them on the left-hand side, I would have to subtract 9x. I tend to put it below my equation to both sides of the equation. And so I would have 3x minus 9x, opposite signs in front of the numbers I'm adding. So I'm actually subtracting. I look at the number that has the without signs. So 9 is bigger than 3 without the signs. So I'm going to look at 9 minus 3, which gives me 6. But 9 had a negative in front of it. So this is going to be negative 6x is equal to 9x minus 9x cancels. And then we can bring down that 6. Okay, so I have all the variables to one side of the equal sign, but I now need to get all the constants, the terms without the variable, to the other side of the equal sign. And so that 6 minus 6x, I don't want that 6 in front of that negative 6x. And so I can get rid of it by undoing it by subtracting 6 on both sides. And so doing this, I get negative 6x is equal to 6 minus 6, which is 0. So I want x equals, I don't want negative 6x equals. So I need to get rid of that coefficient in front of my x value. And I can do that now by dividing both sides by negative 6. So it's okay to have 0 in the numerator. We just can't have 0 in the denominator. So 0 over negative 6. So you're kind of thinking to yourself division. Negative 6 times what gives us back 0? Well, negative 6 times 0 gives us back 0. So we get that x is equal to 0. So we can always go back and we can plug in the value we get for our value of x or our solution set back into our original equation to make sure that it's true. Well, if I go in here and wherever I see an x, I plug in 0. I notice 3 times 0 is 0, so I get 6 on the left. 9 times 0 is 0, so I get 6 on the right. 6 is equal to 6, so that worked. So hopefully that wasn't too bad. And if you needed it, it was a quick reminder on how to solve a linear equation. Looking at problem B here, notice that our sides are not simplified all the way down. And so looking at problem B, we want to solve this. So looking at this, you want to ask yourself, what am I going to do first to solve this? So my suggestion for you as I'm lecturing through, really you guys should be trying to do these problems, especially if you understand how to do them while I'm doing them. And then you can always, if you get stuck, kind of listen to what I'm doing, or you can always go back and look. I appreciate if you guys have any questions, so just let me know if you have any questions, type in or stop me if you aren't understanding something. Okay. So problem B. Notice that we have the parentheses there, and in front of that parentheses, there's a negative sign. So it's like we're multiplying everything through on that parentheses by a -1. We're using what is called that distributive property here. And so we're going to distribute this -1. So it's important that we bring everything down in our equation that we haven't done yet. So I'm going to bring down this 2x or worked with. And then distributing my -1 times 3x, that gives me -3x. -1 times +3 is -3. is equal to 2x minus 18. So now that I've distributed, I notice that I have like terms on the left-hand side of my equal sign so that I can combine them. So I have a 2x and minus a 3x. Those are like terms. So 2 minus 3. So again, I have opposite signs in front of the values that I'm adding. So I'm actually going to subtract. 3 is the bigger number without the sign. So 3 minus 2 is 1, but 3 has a negative in front of it. So this is going to be negative 1x. I don't have to write the 1 there. I can just write it as negative x if you want. And then we have minus 3 equals, and 2x minus 18. Those two terms are not like, and so we're not going to add them. So we've simplified down both sides of our equal sign. We want to get everything again to one side of the equal sign. And so let's move everything that has a variable to the left-hand side of the equation. And how about let's move everything that doesn't have the variable to the right-hand side of the equation. So subtracting 2x on both sides, and let's add 3 to both sides. So we can do this simultaneously if you'd like. So negative x minus 2x, they have the same sign in front of the coefficients that we're adding. So we add them together and then attach on the symbol that, or sign that they share in common. So negative 1x minus 2x is negative 3x. Negative 3 plus 3 cancels, which we wanted, equals 2x minus 2x, those cancel. And we have negative 18 plus 3. Opposite sign, subtract. 18 minus 3 is 15. Larger number has a negative, so this is negative 15. So terms with a variable. There was a question on the text. Okay, and I chat, and I think someone answered it. So let me just finish this and I'll go back and talk about it. And so negative 3x equals negative 15. We want to get that coefficient in front of the negative 3. We don't want that in front of our coefficient. So we can either think of it as dividing both sides by negative 3 or multiplying both sides by negative 1/3, the reciprocal. So if I divide both sides by negative 3, so this is where you're going to have to remember your rules of multiplying and dividing positive and negative numbers. If we divide or multiply and they have the same sign, it's always positive. If we multiply and divide and they're opposite signs, it's always negative. So negative 15 divided by negative 3. Well, 3 goes into 15 5 times. Negative divided by negative is positive. Okay. Okay, so I just answered some questions and went through some stuff with the students with the video off. But now let's come back and look at the next part of this question. So the third equation, we have x plus 4 in the numerator, and that's all divided by 2. Then we have plus x plus 1 in the numerator, all divided by 3. And this is equal to 10. So if you are solving an equation, so it has to have an equal sign in order for it to be an equation. If it's not an equation, we're not solving for that variable. But if you're solving an equation and you have fractions, the best thing to do is first clear your fractions. And so we can clear the fractions from an equation by multiplying through by the least common denominator. So recall the least common denominator, that is the number that is the smallest. Usually you want the smallest value, but you could do bigger. You want the least value, smallest value that both numerators divide into. So 2 and 3 both divide into the number 6. 6 is the smallest number they both divide into. So in this case, our least common denominator, our LCD, is 6. So we're going to use this fact to help us clear our fractions. So remember, if we do something to one side of the equal sign, we're doing it also to the other side. So we're going to multiply the right-hand side of this equation, this x plus 4 all over 2 plus, so technically I have parentheses or brackets here, plus x plus 1 all over 3. This is equal to 6 times 10. So technically that 6, what we multiplied on both sides, that 6 has to be distributed if there's more than one term or grouping on a side of the equation. So technically the 6 here is in front of the x plus 4 all over 2 plus 6 times x plus 1 all over 3 is equal to, well, 6 times 10, let's just simplify that, is 60. So the whole point of us multiplying through by that least common denominator is to clear those denominators. We chose something that those denominators divide into so that we can simplify. We can simplify, you can think of this if it helps you as 6 over 1. And so when you are simplifying multiplication of fractions, we're looking at 2. 2 can go into this 6 3 times. And this 3 can go into this 6 twice. So notice now we have a number in front of parentheses. And so we need to take that number in front of the parentheses and we need to distribute it to each term inside that parentheses. So we need to multiply it to each term inside that parentheses. So we have 3 times x and 3 times 4. So distributing the 3 to the parentheses x plus 4, we get 3x plus 3 times 4, which is 12. Plus, so now we're taking the 2 and we're distributing it to both terms inside the parentheses. So 2 times x plus 2 times 1. So 2 times x gives me 2x plus 2 times 1 is 2. This is equal to 60. Looking for like terms on one side of the equal sign. And so I noticed that 3x and 2x, those both have terms with x on it, raised to the first power, same power on the left-hand side. So we can combine those. So I know 3x plus 2x is 5x. And then I also noticed that I have like terms here, 12 plus 2. Those are both constants. So I can combine those. 12 plus 2 is 14, is equal to, let's bring down our 60. So we've cleared our fractions. We've simplified down each side of the equal sign as far as possible. And now this is where we're getting the variable to one side and the constants to the other. So I don't want that plus 14 on the left-hand side. So to get rid of that addition, we're going to do the opposite, which is minus. So I'm going to subtract 14 on both sides. So doing that, bringing down my 5x. 14 minus 14 is 0. I'm not going to write 0. And then 16 minus 14 is 46. Okay, so divide both sides by 5. And we get that x is equal to 46 fifths. Okay, so I'm questioning myself. Did I do everything right? Just because the answer looks nasty, and I guess our answers are going to start to look nasty anyways, but it might be a good way to recall how to add or how to deal with complex fractions, fractions within fractions. So let's go back and check our solutions. Before I do that, let me see what's going on in the chat. Okay, so looking at our equation, we're going to just go back and check our work. And so wherever we see an x in here, we're going to replace that x with that 46/5. So I would have 46/5 plus 4 all over 2 plus, I see an x, so replace it with 46/5 plus 1 all over 3 is equal to 10. And we're checking this. So we're just making sure that the left-hand side, once we simplify that down, equals the right-hand side. So this is a little messy because I have complex fractions, fractions within fractions. And there's two ways that you can simplify complex fractions. The way that I like the best is to multiply the one fraction by a fancy one, what I call fancy one. That fancy one that you're going to choose is look at all the terms and find the LCD of all those terms. And you can think of those whole numbers of over 1 if you want. And so the LCD of 5, 1, and 1, the smallest thing that 5 can divide into and 1 can divide into would be 5. I can't just multiply by 5 in the numerator, but if I multiply by a fancy 1, 5 over 5, we can do that. So same idea with that second fraction. I can clear that fraction within the fraction by looking at the LCD of all the terms. In this case, it's still 5. So if I distribute my 5 to each term in the numerator, so that's going to give me 5 times this 46/5 plus 5 times 4 all over 5 times 2. Plus, same idea here. So we have to distribute the 5 to each term inside the denominator or numerator. So we would get 5 times 46/5 plus 5 times 1 all over 5 times 3. Does this equal 10? Okay, so we multiplied by that fancy one, the LCD of all the terms within the complex fraction, so that our fractions within the fraction will cancel. So notice this 5 times 46/5, the 5s cancel. So all you're left with for that piece is 46. Plus, we have 5 times 4, which is 20, all over our denominator, 5 times 2, which is 10. Plus, so over here in our second fraction, the 5 cancels for that first term in the numerator, and we're left with 46 plus 5 all over 15. Does that equal 10? Order of operations, we'll simplify our numerator first before we divide. So we have 46 plus 20, and that gives me 66 all over 10. Plus 46 plus 5 is 51 all over 15. Is this equal to 10? So two things that we can do here. We can either combine those two fractions on the left-hand side as one fraction. If we do that, we need to get the least common denominator first before you can add or subtract fractions. Or we can do what we had done for solving the equation. We could simplify or get rid of the fractions within the equation by multiplying through by the LCD. So this could be kind of good practice for finding the LCD between 10 and 15. When you're looking for the LCD, when they both have some factors that are common, sometimes it's easiest if you go through and you rewrite it as prime factors. So I can rewrite 10 as 2 times 5. 2 is a prime number, and so is 5. And then I could rewrite 15 as 3 times 5. So the LCD, when you're finding the LCD, you're looking at the number of times each factor occurs into something, one of the numbers that we're trying to find the LCD the most. So if I look at the factor 2, 2 is only in a factor of 10, and it only occurs once. So most time it occurs in either one, 10 and 15 is once. So I need 1, 2 in here. The next prime number I see is 3. 3 occurs in each factor. Well, it only occurs once in one factor 0 times. So most times it occurs is once. So I need a 1, 3. If I look at 5, 5 occurs in a factor of 10 once, and it occurs in the factor of 15 once. It is the most time it occurs in either one is once. So I just need 1, 5 here. So if I multiply 2 times 3, I get 6. 6 times 5, I get 30. So my LCD for 10 and 15 is 30. So I could go through here and multiply each equation by 30, or each side of the equation by 30 to clear my fractions if I wanted. Or I can get the LCD of 30 on both of those fractions and combine it as 1. If I multiply 30 on the left-hand side of the equation, I have more than one term, so it has to distribute to each one of those terms on the left-hand side. So we're given that 30 all times 66 over 10 plus 30 times 51 over 15 is equal to 10 times 30, so that's 300. So now that I multiply both sides by my LCD, the sides with the fractions, the denominator is going to be able to cancel out. So 10 goes into 30 3 times. So I'm left with 3 times 66. Let me just do that real quick. So I know 3 times 6 is 18. So I'm going to put an 8, carry my 1. 3 times 6 is 18 plus the 1 I carried. So that gives me 19. So 3 times 66 should be 198 plus, okay, well, let's simplify here. 15 goes into 30. 15 goes into itself once and 30 twice. So I technically have 2 times 51 left. 2 times 51 is 102. Is this equal to 300? Yay. Yes, it is. So 198 plus 102 is 300. 300 equals 300. So we checked our results and showed that our solution that we found was true to that equation. Oops. So just kind of want to shrink the page so you could see all the work in there. Okay, so in front of you now are 2 more equations. So let's look at solving these. I'm looking at 2a, which is 1/4 plus 6 over x is equal to 5/8. Looking at this, I can't simplify either side of my equal sign right away. I notice I have fractions. The thing in this case, different than the other case that we just looked at, is that notice that the fractions, what's in the denominator, we actually have a variable, where the other example, we didn't have a variable in the denominator. If you have a variable in the denominator, we have to look at values that x cannot be. Sometimes when we solve equations, we get what are called extraneous solutions. So we get solutions that we find for a variable, which actually do not work when we plug them back in. And you could possibly get extraneous solutions when you're looking at solving equations that have fractions and variables in the denominator. So remember I had said we can never have 0 in the denominator. It was okay to have 0 in the numerator when we were solving that one equation, but we can't have 0 in the denominator. So in this case, I have to look at what value of my variable would put 0 in the denominator. Well, I just have that x in the denominator, so I know here that x cannot equal 0. So if I go through and I find the solution and I get x is equal to 0, I need to exclude that from the solution set. So now looking at this, because I have fractions, I need to find my least common denominator. So my least common denominator of 4x and 8. So all of those values I just gave you has to divide into evenly the value that we choose for our common denominator. And our least common denominator, well, since 4 divides into 8, another value in our denominator, 8 is the smallest thing that 4 divides into and 8 divides into. The problem is that x doesn't divide into 8. So our least common denominator would have to be 8 times x, or 8x. So we're technically multiplying each side of this equation by our LCD, which is 8x. If I distribute my 8x to each term on the left-hand side of my equation, I would be left with 8x times 1/4 plus 8x times 6/x is equal to 5/8 times 8x. So now let's simplify. So 4 goes into 8x 2x times. So we're left with 2x for that first term. Plus, so 8x times 6/x, the x cancels. And we're left with 8 times 6, which is 48. Equals, so I have 5/8 times 8x, the 8 cancels. So I'm left with 5 times x, which is 5x. So 2x plus 48, those are not like terms, I can't combine them, is equal to 5x. So this is a case where I would probably get my variable to the right-hand side of the equal sign, because my constant is on the left and there's only one constant. And so I could subtract 2x to both sides of my equal sign, bring down my 48. 2x minus 2x cancels. So 48 is equal to 5x minus 2x, which is 3x. Get rid of the number in front of the x. We could divide both sides by 3. So 48 divided by 3, that goes in 16 times. So we have 16 is equal to x. So I want to know that you are checking that this is not one of the values that our variable could not be from the original when we started. X equals 16 does not set our denominator equal to 0. So as long as we did our arithmetic and algebra right, our solution is 16. So if we go back in there and plug in 16 for x, we should get it a true statement. Okay, so I don't see anything in the chat, so I'm just going to move on to the next problem. And now I see that there is a in the chat on how we got 8 as the LCD. So we got 8x as the LCD, So to find the LCD, again, what you want to do, and then what would the check look like was another question. So LCD, how we do this, you're going to look at all your denominators. And so notice that we have 4 in the denominator. And so what you want to do is you want to break down the number in the denominator as prime factors. So I don't know if you guys remember your tree diagram, where you think of 2 numbers that multiply to give you that number above, and they don't want to be 1 in itself. And so there's 2 numbers, 2 times 2, that gives us 4. 2 is prime, so if they're prime, we're going to keep them. If they weren't prime, we would go down further. So for 8, we have 2 times 2. So other variable or other term in our denominator is x. Well, there's no factor that we can rewrite x, so it's just x. And then 8. So if you look at 8 and you do your tree diagram really quickly, 2 numbers that multiply to 8 is 4 times 2. 2 is prime, but 4 is not. So I'm going to look at 4 and break it down in primes. 4 can be written as 2 times 2. So the prime factorization of 8 is 2 times 2 times 2. You multiply 2 times 2 times 2, you get back 8. So for LCD, you look at the most time any factor occurs in the prime factorization. So the most number of times that a 2 occurs and either number in the denominator is 3 times. So for the LCD, I need 3 2s. So let's just cross out the 2s. We already got that. The only thing that's left is an x. Most number of time x occurs in any 3 of those denominators is just 1. So I need 1x. So if we multiply 2 times 2, that's 4. 4 times 2 is 8. And so this gives us 8x as our least common denominator. Okay, so we have another linear equation in front of us. It actually is not linear when we start, and I'll show you why, but it ends up becoming a linear equation as we go through and we simplify. So notice that for 2b, that b is the letter, it's not part of the equation. So for part b, we have x times parentheses the quantity 2x minus 5 into parentheses equals parentheses 2x plus 2 into parentheses times the quantity in parentheses x minus 3. Okay, so first thing that we need to do is we need to simplify each side of these equations by our equation by distributing. And so for this first piece, I have x times 2x. So if I do x times 2x, that gives me 2x squared. X times x is x squared. And then I have x times a negative 5. So this gives me minus 5x is equal to, so I have a binomial times a binomial, meaning I have something with 2 terms times something with 2 terms. And so notice when you have a binomial, you have to take each term in the first parentheses and distribute it to each term in the second parentheses. So I need to look at what is 2x times x. Well, 2x times x is 2x squared. I have to look at what is 2x times negative 3. That gives me minus 6x. Now I have to take the next term in the first parentheses and distribute it. So I have 2 times x, which gives me plus 2x. And I have 2 times negative 3. And 2 times negative 3 gives me minus 6. So looking at this, I want to simplify down each side of my equal sign. 2x squared minus 5x, those are not like terms because both of them the x are not raised to the same power. So we can't simplify down the left-hand side, so I'm just going to rewrite it. So I have 2x squared minus 5x. So looking at the right-hand side of my equation, combining like terms. So 2x squared, I don't see any other like terms on the right-hand side, so I'm just going to rewrite 2x squared. But next I have a negative 6x plus a 2x. So negative 6 plus 2. 6 minus 2 is 4. Negative 6 plus 2 would be minus 4x. And then minus 6. So when I have an equation which is quadratic, this is a quadratic equation right now, because if you look at the exponent of my variable x, I have a 2 up there. That's the highest exponent. And so this is a quadratic or degree 2 equation. Usually I solve those differently than linear. If it's a quadratic, a lot of times we will get everything to one side of the equation and set it equal to 0. I noticed though right away, if I subtract 2x squared on both sides, notice that this is no longer a quadratic equation because those terms with the x squared cancels out. And so 2x squared minus 2x squared cancels. I'm left with negative 5x on the left-hand side is equal to 2x squared minus 2x squared cancels. So minus 4x minus 6. So now I'm left with a linear equation. So I'm going to proceed by getting all the terms with the variable to one side, get the constant to the other. So it looks like it's easiest if I add 4x to both sides. I can get all the variables to the left-hand side of the equation. So I have a negative 5x plus a 4x is a negative 1x or negative x is equal to negative 6. I want x equal, not negative x equal. So we can either divide both sides by negative 1 or multiply both sides by negative 1. We'll get the same result. And so we get x is equal to negative 6 divided by negative 1, which is positive 6. So we have 2 more equations in front of us now. We have part C of 2. And we have part D of 2. So part C, we have x all over the quantity x minus 6. And then we have outside of that fraction plus 1 is equal to 6 all over the quantity x minus 6. Okay, so we have a variable in the denominator in this case. And so we have to be worried about the value of the variable, which sets our denominator equal to 0. So I know that x minus 6 cannot equal 0. So x could not equal 6. So as long as I don't get a solution of x equals 6, we're good, and I don't make any errors. If I get a solution that x is equal to 6, then we have to exclude it from the solution set. So I have an equation here, and again, we have fractions. We've figured out what x can't be, but we want to clear those fractions. And we can only clear those fractions again because this is an equal sign. And so whatever we do to one side of our equal sign, we want to do to the other side. We'll notice that the only thing that we have in the denominator in each case is x minus 6. And so x minus 6 is our LCD. So to clear our fractions, we're going to multiply our LCD, x minus 6, to both sides of our equation. And I'm just going to write it up here to save some time with writing. Notice that we have 2 different groupings on the left-hand side. So that x minus 6 needs to be distributed to each piece on the left-hand side. So doing that, we would get x minus 6 all times the quantity x all over x minus 6 minus x minus 6 times, actually it's plus, plus x minus 6 times 1 is equal to 6 all over x minus 6 times x minus 6. Okay, so now that we multiplied through by the LCD, we distributed on the one side. Now we can start canceling like terms in the numerator and denominator. So here our x minus 6 cancels. And so we're left with 1 times x, or x, plus, well, 1 times anything, and it's positive, so I don't really need those parentheses there. So 1 times anything is that anything. So it's really just x minus 6 is equal to, and then on the right-hand side, again, those x minus 6's cancel. And so we're left with 6 times 1, which is 6. So we've cleared our fraction. And so now we want to simplify each side of our equal sign down. And so we have x plus x, which is 2x. 2x minus 6 equals 6. We want to get x by itself. And so we could add 6 to both sides of our equal sign. And so we get 2x equals 12. If we divide both sides by 2, I get that x is equal to 6. Okay, so notice at the beginning we said x could not be equal to 6. And so since that can't be part of our solution set, and that's the only answer that we got, there is no solution to this equation. So the next question, part D of 2, we have 5 all over the quantity x minus 2 is equal to -3 all over the quantity x plus 2, plus 28 all over the quantity of x minus 2 times the quantity x plus 2. All that x minus 2, x plus 2 is down in the denominator. We have fractions. We have variables in the fractions, so we have to be careful of values which make the denominator equal 0. So I noticed that x minus 2, this piece down in the denominator, if x is equal to 2, that would make the denominator equal 0, so x cannot be 2. If I look at the denominator x plus 2 is equal to 0 when x is -2, so x cannot be -2. Those are the same thing for x minus 2, x plus 2 over here on the right-hand side. So those values cannot be part of our solution set. If I look at this, you have more than one term in the denominator. So you have addition or subtraction in between terms. You need to be careful when you find the LCD. So the LCD, even though they both have an x and a 2 in there, they're different factors. So x minus 2, that occurs once. That's the most times it occurred in any denominator. And 1x plus 2, the most times that factor, x plus 2, occurs in any of those denominators, which is once. So our LCD is this x minus 2 times x plus 2. So let's clear our fractions by multiplying the left-hand side by our quantity x minus 2, x plus 2. And our right-hand side by the quantity x minus 2, x plus 2. There's only one term on the left-hand side, so there's no distributing that needs to happen there. So we have x minus 2 times x plus 2, all times the left-hand side, which is 5 all over x minus 2. is equal to, but on the right-hand side, we need to distribute that whole quantity, x minus 2, x plus 2, to each fraction on the right-hand side. So if we do that, we have -3 all over x plus 2, all times x minus 2, x plus 2, plus 28, all over x minus 2, x plus 2. Distributing this times x minus 2, x plus 2. So now that we've distributed on both sides of the equation, we can go through and cancel like factors. If it helps you to see it, you can always take your LCD and put it over 1. So like factors in the numerator and denominator are x minus 2. The only reason we can cancel those factors x minus 2 is because it's strictly multiplication in between. So I'm left really with this 5 times this quantity x plus 2. So let's just simplify right now by distributing that 5. So I have 5 times x, that's 5x, plus 5 times 2, which is 10. This is equal to, so on the other side, canceling like factors in the numerator denominator, first grouping x plus 2 is the same. So let's take this -3 here and let's distribute it to the factors that is left, x minus 2. So I get -3 times x is -3x, and -3 times a -2, negative times negative is positive 6. Plus, so again, let's cancel like factors in the numerator denominator for the second grouping on the right-hand side. Well, x minus 2's cancel and the x plus 2 cancels. So technically we're left here with 28 times, we are left with a 1 if everything cancels. So 28 times 1 is 28. So go through, simplify each side of the equation down, 5x plus 10. Those are not like terms, so I'm just going to rewrite it. 5x plus 10 is equal to -3x. And I see 6 plus 28, those are like terms. 6 plus 28, that gives me plus 34. So if I move where I want the variables on the left-hand side, that would mean I would want to add 3x to both sides of the equal sign. If I want to get the constants to the right-hand side, that means I don't want the 10 on the left-hand side. I'd have to subtract 10 on both sides to get rid of it on the left. So combining this, 5x plus 3x gives us 8x. 10 minus 10 cancels. Equals 3x minus 3x cancels. 34 minus 10 is 24. So we've simplified variables on one side, constants on the other. Get rid of the coefficient in front of the variable. We can do that by dividing both sides, in this case, by 8. So we get x is 24 divided by 8, which is 3. I would go back, I would check to make sure that was not one of the values what set my denominator equal to 0, and it's not. And so as long as I did my algebra correctly, I get the solution that x is equal to 3. Okay, so looking at our next question, and we have an application problem. It says a total of $51,000 is to be invested, some in bonds and some in certificates of deposit, CDs. If the amount invested in the bonds is to exceed that in CDs by $3,000, how much will be invested in each type of investment? Okay, so application problems, read through. Might have to read it through a couple of times, and then let's go through and start picking pieces out. So we need to sometimes, we need to assign in a variable and what that is representing. And so usually you can figure out what the variable is based off of the question. So how much will be invested in each type of investment? So recall we have 2 types of investments. We have bonds and we have certificates, CDs. if the amount invested in the bonds is to exceed the CDs by 3,000. So let's say X equals the amount invested in CDs. If we know that the amount has to exceed $3,000 for the bonds of the CDs, we know that it exceeds. That tells me that it needs to exceed by 3,000. So X plus 3,000, the amount of the CD plus 3,000 is equal to the amount invested in bonds. Okay. So we have 51,000 is to be invested, some in bonds and some in certificates of CDs. If the amount invested in the bond is to exceed that in CDs by 3,000, how much is invested in each account? So I know that the amount that I invest, now I'm coming up with another equation to help me solve this. So I know the amount that I invest in CDs is X plus the amount that I'm investing in bonds, which is X plus 3,000. The total amount invested in both is $51,000. So I typically kind of write word problems in 3 parts. Part A, define what your variable is and what it represents. Part B, set up your equation or equations. And part C is the solution. Okay, so let's look at part B. We want to solve that equation to get our solution. So I noticed that X plus 3,000 equals 51,000. I noticed that on the left-hand side of this equation, I have like terms, X plus X. So I can rewrite that by summing it. X plus X is 2X, and then plus the 3,000. This has to equal 51,000. We want to isolate our variable, so we're going to subtract 3,000 on both sides of our equal sign. So we're left with 2X is equal to 51,000 minus 3,000 is 48,000. Get X by itself, we can divide both sides by 2. So we get X is equal to 24,000. So part C, it wanted to know how much we're investing in each type. And so for our CDs, this is equal to X, and X was 24,000, but we're talking about dollars. So let's put the dollar sign, $24,000. For bonds, it's X plus 3,000. So if I plug in 24,000 for X, 24,000 plus 3,000, that is 27,000. So we answered the question. If we have $51,000 to invest, 3,000 for bonds has to exceed what we put in for CDs. We have 24,000 in CDs and 27,000 in bonds. Okay, so we're going to stop here. We only got through 1.1 in our textbook, solving linear equations. So that's the only thing that will be due for this class at the end, at the beginning of next week on Tuesday by 8 a.m.